Hi, this is Tom Herman with the Bedding, Bathing, and Yonder Analytics team, here to talk to you today about our current loyalty customers, their household spending habits, and how we can use that information to predict our prospective customer spending and better inform our future marketing activities. More specifically, we'll talk about the overall analysis approach, the methodology. We'll take a deep dive to better understand our current loyalty customers. We'll talk about the actual model we produce to predict our future prospect customer spending, and you'll get to see the actual output. So before we dig in, what are we really talking about here? What's our opportunity? At the end of the day, we have a ton of great data about our current loyalty customers, and we're trying to better understand who they are and how we can use that data to better target our prospect customers, our future customers. So why don't we use that current data that we have to predict our future customers' behavior and spending patterns to help our future marketing efforts? So this analysis was constructed using the SEMMA data mining workflow. And in the first section, in the sample section, we took our current in-house loyalty customer data, enriched that with additional data that we purchased from third parties to help us understand our customers, removed some potentially sensitive attributes that we wouldn't want our models learning on or making predictions off of, did a bunch more data cleanup, added some variables that the model might find useful, and then ended up with a training data partition of 13,500 current customers, tested that on a separate partition of 5,000 additional customers to evaluate the performance of the models. In the explore phase, we looked at our current customer information, things like where they're located, their spending levels by various criteria, and more that you as our data science peers and marketing folks might find useful. In the modify section, this is where we started to prepare the data for modeling. So iteratively figured out which variables the models found the most influential or not, removed as many variables that we could to make a parsimonious model, used variable treatment to prepare the data for the algorithms, and of course the thing we're trying to predict here is called Y hat in the model, which is basically the household spending. Finally, in the modeling section, we created 4 models, actually more than that, but 4 that appeared to be working well to attempt to predict the prospective customer spending. Those were a random forest, generalized linear model, gradient boosting machine, and XGBoost in this case. And then finally assessed each model based on various performance metrics and chose a final model to actually predict those spending amounts for our prospective customers. So before we talk about the models and the predictions, let's talk about our current customers and what we can learn about them. Here we've got some location data that marketing might find useful in terms of, who they approach and where we might get some efficiencies. On the left-hand side is a heat map view, and you can see we're dispersed all over the 50 states, which is great, but there's a clear concentration in that Ohio River Valley, kind of eastern seaboard area. And we also created a cluster view. We can actually zoom in and out on this to get, more detailed clusters if we want, but you can see that kind of reinforces the concentration you see on the left there. So here's a snapshot of how much our loyalty customers are actually spending with us. You can see the distribution here. The average is about $315 with a median slightly lower, $300, but you can see most of them are somewhere around $250 to about $400. We were expecting to see some different spending behaviors based on net worth ranges or education levels. As you can see here, the median spend is pretty consistent across both net worth ranges as well as educational levels. Interestingly, our customers who reported owning a computer have higher and more consistent spending, as you can see from the density plot here. Those 1/3 of customers that we don't know if they have a computer, you can see by the pink distribution, they're more varied and dispersed in their spending. Since we paid for additional data about our customers' magazines and how many they have in their homes and what kind of magazines, we actually engineered a new variable called magazine enthusiast that tallied up the number of magazines that our customers have in their homes. And it turns out that those with lots of magazines tend to spend less, and those with fewer magazines tended to spend more. As you can see here, there's actually a slight negative association between household spending and number of magazines in the home. Even specifically looking at do-it-yourself magazines, which you would think would kind of fit well with the types of products that we offer, those customers with specifically just that magazine showed the same trend. So that's definitely interesting for marketing in terms of how they look at the channels that we want to use to market our products. Since we also have Experian persona data, we took a look at, which personas, if any, are doing more spending than others. And you can see here on the chart, there's a few that have disproportionate spending, the 5 blue highlighted at the top. And as you'll see on the next slide, we were able to obtain some of these actual personas for you and our marketing folks to take a look at. And here you can see some screenshots of a few of these actual personas. We've got Metro Fusion, Homemade Happiness, colleges, and cafes. If you or marketing want to take a look at these in more detail, there's an Experian Mosaic USA e-handbook that's out there. It's sourced here. You can click on the link. I would note a couple of these appear to have changed, so they're no longer, in the latest catalog, but you can take a look nevertheless. So moving on to the modeling process, we used 4 different algorithms to come up with some various models here. So the first model we created was Random Forest. That was just as a baseline model because Random Forest is versatile. It can handle complex relationships, avoid overfitting, and then it was also useful for determining the variable importance. So in a bit of a circular fashion, we ran the Random Forest variable importance and then circled back to winnow down the number of variables that were going into our model that actually weren't that useful. They weren't really helping our predictions. So that was the first model, followed by generalized linear model, which you'll see subsequently as GLM. Just as another reference point, that's a traditional model. It also gives a summary where you can see variable importance, so that would help inform that. And then moving on to a couple of tree-based algorithms, gradient boosting machines, another one that's great at handling complex data sets, especially with non-linear relationships. And then since that one appeared to perform pretty well, the final model we used was XGBoost, which is basically an optimized version of the gradient boosting machines model. Just to note, we also use k-nearest neighbors, which the metrics didn't look that great, so that's not included here. We attempted to create an ensemble model of these 4 models, but that didn't really seem to help our performance metrics either, so abandoned those. But as you'll see on the following slide, we'll actually dive into some of the metrics. On this slide, we're actually getting into the performance metrics of the models on our training data. We've got R squared, root mean squared error, abbreviated here RMSE, and mean absolute error, abbreviated MAE. And the initial metrics here suggest that XGBoost was the most accurate model, which you can see highlighted in orange. So for R squared, we want the highest value we can possibly get. For RMSE and MAE, we want the lowest median values. So in this case, XGBoost exhibited the highest median R squared value, which means that approximately 55% of the variance in household spending can be explained by features in the model. The model's RMSE of 65 means that the predicted household spending was off by $65 on average compared to the actual values. RMSE gives more weight to larger errors, unlike mean absolute error, which simply measures the average absolute difference between the predicted and actual values. So in this case, the MAE of 51 means that the predicted household spending was off by $51 on average compared to the actual values. So with the highest R squared and the lowest RMSE and MAE, XGBoost appears to be the best model, but is going to be further assessed on the following slide. So we went ahead and applied all 4 models against the separate test data partition. And what you see here is a comparison of metrics between the training data and the testing data across all 4 models, all the metrics. And they're all very consistent, which makes me not worry too much about overfitting. There's no major drops in any of these metrics or major increases. And you can see highlighted at the bottom in green, XGBoost continues to have the best scores here. Root mean squared error, it's hanging steady at about $65. considering a median spend that we saw earlier is about $300 per customer, $65 seems fairly acceptable to me. Our R squared is the highest at about 56%. Our mean average error is at about $51. And then we have a new metric here, shown here as MAPE, mean absolute percentage error, which just expresses our prediction errors as a percentage of the actual values. So as we can see, all models are strongly consistent between training and test, but there's a clear winner across the board, and that's going to be XGBoost. So let's go ahead and predict our spending using XGBoost as our finalist model. So we went ahead and applied the XGBoost model to our prospect customer data, and the output here is a CSV file called Prospects Predicted Spending. You're going to see the predicted spending amounts on the far left, and we went ahead and kept all of the enriched data in there just so you have it if you need it. You've got the donation, magazine, political data, all of it in there. And as a final note, I would say that the household spend prediction column is sorted top to bottom. So you're going to see the highest spenders at the top, which is predicted to be about $358, all the way down to the lowest at about $76. So clearly some great differentiation and targeting opportunities for marketing based on the predicted household spending and other customer insights provided in the analysis. Just as a final note, now that we have that prospect data with the predicted household spending, just want to acknowledge at a really high level some similarities and differences relative to the current customer information we looked at before. So in terms of location, on the left-hand side here, you can see that our prospects are very similar. We've got clusters in that Ohio River Valley area, the eastern seaboard, very similar to what we saw with our current customers. We've got some Experian Mosaic persona similarities and differences. So we've got 3 new personas rising to the top. So I would encourage you to take a look at those personas in the Experian handbook that we saw before. But we've also got number 4 and 5 are the same. So those definitely seem like good personas to target. And then finally, we looked at computer ownership earlier. Our prospects are basically at the same ownership rate at about 73%. So just to recap, we took a deep dive into our current customers. We looked at a few different models, how they performed, used the finalist model XGBoost to predict our prospect spending, and then looked at our prospects a little bit relative to our current customers that we saw earlier. You can find the output, the files, as mentioned before, in the CSV file. I hope you found this informative, and certainly feel free to follow up if you have any questions. I appreciate your time. Thank you for joining me, and have a great rest of your day.